So yes, welcome. Today we're going to be hacking satellites with software-defined radio. You might find some of this interesting. What you're going to learn today, who has a gate that does this when you press a button, one of these? Have you got a key? Will you take them out? We might play with them in a moment. So I'm going to teach you how to do something bad with that. If you're worried about where ships are, if you ever go to the sea, I'm going to show you how to track where those things are in real time, no internet. Same thing with planes. I'll show you how to track planes. So the next time you're picking up a friend at the airport, you'll know if it's delayed. If your flight is delayed, you don't need an internet connection or worry about Wi-Fi. You can just figure out when that's going to happen. And of course, we're going to mess around with some signals from some satellites. So let that animation complete. I just want to put the brakes on here. If you do stupid stuff, you're adult and you can go to prison. I will show you many and interesting new ways of going to prison if you're looking at doing that today. And then this talk is really just about my journey and what I've been learning about. So I'm quite new in the security field. I don't work in the security field. I'm a software developer. I work for a bank. So yeah, this is just about what I've been messing around with. So I'm going to show you the stuff that's worked for me and what hasn't worked for me. And if you've got any ideas about stuff you think I should try or want to chat about, do come to me afterwards. We can chat about that. So a little bit of history. Where does this come from? Who here makes videos? Okay. Some of you might not put your hands up because you make other kinds of videos for the internet. So about 10 years ago, if you wanted to, or not 10, maybe even 20 years ago, if you wanted to make any kind of high-class video production, you'd need a rig pretty much like this, right? With, I hope you can see my laser pointer, but anyway, there's some DVDs down there, so this is a little bit more modern. But anyway, you'd need a lot of equipment, but today most YouTubers are doing something like this. And similarly, my late father was a radio amateur, and I grew up thinking that all men have a Radio Shack full of crap like this. And that was just normal. But no, in fact, today, and I'll show you how and why, it's pretty much just as simple to mess around with software-defined radio. So how is that possible? There was a Kickstarter, and surely, yes, this was possible before, but I think it really kicked off in 2014 with a Kickstarter for this called the Hack RF1. Does anyone have one? One person's got one. 2 people's got one. Awesome. So it started by a guy called Michael Osmond. It's a little bit, maybe twice the size of a Raspberry Pi, and works anywhere between 1 megahertz up to 6 gigahertz. It can both send and transmit, so we say RX and TX. It's got a cool ARM chip in it, and it only costs 10,000 rands. That's right, folks, only 10 grand. Some people are getting better deals than when I was looking. But you have to chat to those people afterwards. Yeah, well, speaking of. Meanwhile, who wants to guess what this is? It's the rollout of digital terrestrial television, and I don't know why South Africa is blue, because why is it blue? They say it's launched, but whatever. And it's created this whole market. Speaking of China, they produce these awesome chips, these Realtek's RTL2832Us, which go in little dongles like this. And here's one. I've got another one there as well. And they operate anywhere between 25 megahertz and 1.6 gigahertz. They're read-only, which is fine. You can get yourself into less trouble. We'll chat about how you get into trouble there if you really want to. They use this chip, of course, and then you cost about $300. So that's really not bad, up to about 500. And there's this whole new blog. So many of the stuff that I'm going to be chatting about comes from this website, SDR.com. So even more crazy things are posted up here. So that's a really good source. And then there are much nicer ones like this one that's got aluminium in it, so you can work at higher frequencies for longer. So that's what that one looks like. That's what that terrible sound was earlier. I was messing around with that. I was trying to get my mic on the RTL SDR to show you that, but I couldn't control the volume. So sorry about those folks' ears. But it's pretty much the same thing, just a little bit more expensive. And there are hundreds of these kinds of devices coming out. They're available on things like micro-robotics, Communica, etc., all selling them now for around $500. There's an AirSpy device, is another nice option. And when it comes to the kind of software for those, Windows. I forgot which crowd I've got here today. But anyway, if you are a Windows user, this is normally how you'll get things going. So AirSpy makes some of these devices. You can just download their software over there. You guys know how to click download. So once you've got that going, what I like about AirSpy is they actually give you a link. This little batch file over here is going to download the drivers for your RTL SDR, which is pretty cool. And once you've got that installed, this is just how you'll get an RTL SDR going in Windows. You open this little program called Zadig. It's going to patch a driver for you, install that. This is generally what it looks like. There you go. This is all real time. I haven't sped this up because I'm far too lazy. Dun, dun, dun. And it's installed successfully. And then you can start a program called SDR Sharp, which in my experience is one of the more popular versions that people are using out there. So this is what it looks like, and you're just going to have to go to settings and select your USB device over there. So if you've got that going, that's it. So this is very much what the spectrum's looking like. And this is called the waterfall down here, so you can just pick up. That's just a normal radio station at 104 megahertz. And this is where we can start playing with one of those key fobs. Have you got these out? So if you've got one, now, not all of them are like this. Yes, there are rolling codes and French encoding and everything else, but most property developers are cheap and like buying cheap stuff. So I was just messing around with one of these as well. So use RTL SDR. These things run at, I think it's 405 megahertz. So let's look what I recorded. 403. 550, there we go. And you press play over there to record that. And if you press that button, you'll see that little code over there. So that's fun. Let's go do some signal analysis. I actually bought the part that you attach to your gate to actually flip the relay over there to open everything up. This brown thing is the antenna. And well, how does this work? You press the button, there's some sound, boom, and the little LED goes. So what's fun about this is you can record that using some of the recording stuff down here. And this is a little bit just like audio recording, 16-bit PCM, see that? And it's exactly the same experience. You're just going to record this. There we go. We've got that. And now let's go see what that signal looks like inside. So who uses Audacity for audio and stuff like that? You use that for this as well, or you can at least. So if I open this up on Audacity in Windows, and I did this all through a virtual machine in my defense, which caused me problems you will see about later. But anyway, that's the signal that I recorded. And if we zoom in there, is no one impressed that I'm doing this with my thumb live? Is no one impressed? Notice that this thing's, it sends the signal quite a couple of times. And if you look at that, I think that's Manchester encoding. I can't remember what this is called, actually. But that looks like a code. And if you had to open up your, I want to call it a dongle because I use Apple computers, but forgive me on that. Yes, so see those dip switches over there? That's how you set that static code. And you'll notice a very probably expected for this audience correlation between these over here. So that's an interesting new way of going to jail if you want to open up things or record these. And in fact, when I was messing around this, I noticed that I was getting signals when I hadn't pressed the button, and it was my neighbors coming home and stuff like that. And you'll be surprised how often it's a static code that keeps being reused. So let's talk about why we get into trouble when we mess around with the electromagnetic spectrum. On the back of your phone, you'll normally have something like this. So the FCC is from the States and EC is from the UK. And these guys regulate what part of the spectrum who can use, or who can use which part, and different parties have paid different amounts for people to be allowed to use different parts of the spectrum. So it's sort of policed. So ICASA is the South African version of that. I believe this is the one for China and Malaysia, and one of them here I can't remember is for New Zealand. And this is a nice graph just to show you where all the different parts are allocated. So this is normally where normal broadcast radio would be sitting, the kind of stuff you listen to in your car. If we go over to 2.4 gigahertz, that's where Wi-Fi and Bluetooth and all those good things sit. So that's kind of like unlicensed. It's free for us to use. And going over to this side, we've got 890. What was this? Oh, yes, aeronautical mobile stuff. So we're going to mess around with some planes a little bit later. On this side, the satellites fit in there, in this 137 megahertz range. It's a little bit tight. And then all the way on that side, this is where those key fobs, so your car remote and all those different things sit in here. So that's quite fun. And if you do want to extend this a little bit further, I would very much recommend getting an amateur radio license. Who here's a radio ham? Okay, more than I've had before. You guys, the guys who like being referred to by your ZS whatever call signs. Okay, I'm not a radio ham yet. I have accepted Dominic White's challenge to go and do both my parents are radio hams, so I beg your pardon? Yes, I am doing it. It's just taking long. And how I'm doing it is weprepare.co.za is a cool website where you can do practice exams even. So I recommend that to anyone interested. Who here has a Raspberry Pi? Who does not? What is wrong with you? Why don't you have a Raspberry Pi? Okay, for those of you who don't know what a Raspberry Pi is, credit card sized computer, about yo-high, $600, cool little ARM processor, and did you know this? It's TX only. As far as I've been able to find out. Anyway, between 5 kilohertz and 1.5 gigahertz, which is actually quite impressive. Guy who got this going created something called RPiTX. Very fun piece of software. And the way you get this going, and I'll show you why you shouldn't do it just like this yet. But anyway, if you look at your general input-output GPIO headers, if you attach just a little lead onto GPIO 07, which I think, correct me if I'm wrong, is the one used for pulse width modulation on motors, you can use that to broadcast stuff. But I warn you, please do not do this, because a Raspberry Pi is a digital device, so it thinks in ones and zeros, and that normally gets broadcast as a bit of a square wave. And those of you who remember your high school computer science, and for other computer science, what am I saying? Physical science. When we broadcast things, we want to use nice sine waves. I'll show you why in a moment, because of this harmonics problem. But because we can use constructive interference and destructive interference to create different waveforms, and if we add some more up, we can make square waves. The same thing is true in reverse, which causes this terrible problem. So if you're going to be using a Raspberry Pi to transmit any of these things, that whatever you're broadcasting is going to be sort of reflected on different parts of the spectrum as well, and you're going to start breaking people's baby monitors and upsetting all kinds of people. And the worst part is you're telling them exactly where you are by broadcasting that signal. So you've been warned, and a caster will come after you, but it's fine. There are these things called bandpass filters, so this is what you should use. And essentially all this does is it cuts off the frequency on either side so that those harmonics don't end up in other parts of the spectrum where you cause trouble for people. Very cheap, buy them from China. I haven't bothered yet. Don't tell anyone, but I'll show you why it's cool and how you can do this. Everything leaks electromagnetic radiation. We'll chat about that in a second. So if we wanted to turn our key fob into one of these, or rather the other way around, we could do a replay attack with something like this. So what I've done is I've attached that RTL dongle to a Raspberry Pi over here. That's the antenna part over here. And I can SSH into my Pi. You guys all know how to do that. And from the command line, I love this kind of audience where I can do this. RTL menu is a nice piece of software. So I can go back to that frequency I had before. And I'm just choosing an input and an output frequency. And I want them both to be the same because I'm doing a replay attack here. Attack. Anyway, so while that runs, cool. It's busy recording a signal. So then I can go to my dongle and I can go and, oh, is it shaking because it's playing? No, there we go. So we get that going. Cool. And then I can run it again. So from the menu, I can just replay what I've recorded. So I'm basically just recording something and then playing it back. I want you to notice something. I've not attached anything here. It's just the normal electromagnetic leakage from this thing, which you can see is certified. It's still leaking enough for me to be able to trip this relay. So that's pretty cool. If you think about it, you could just go and plug this thing into a battery pack and connect it, just press it up against the receiver, and you should get enough leakage for this thing to work. Sorry if that's a little bit annoying. I'm just playing on. This can work as a transponder mode as well, basically just a repeater and a few other cool hacks. So that's a more interesting way to go to jail. But can you do a brute force attack? So I thought about this, and there are only 12 switches, and they've only got 2 positions. So the total amount of combinations that this thing can have is only 2 to the power of 12, which is 4,096 combinations. That's not too bad for brute force at all. So if you were to write a piece of software like this, which I just called brute force, you could just transmit, I had to speed this up, for every single code for all these static things, and you could run through all of them, and boom, there, that's done. In fact, I didn't have to wait for it. Meanwhile, cool, huh? So I thought about, I started this on GitHub, and then I took it off when I realized I'm not worried about people stealing things from your home. I'm worried about your dogs getting out and stuff like that. So yeah, maybe I need some. Oh, yes. So the last time I did this at OXCon in Joburg, a guy called Skull came over to me and showed me how he's using this. Who has RoboGuards at home? Okay, do you know what a RoboGuard is? This is a South African product. So what they've got, it's 2, I suppose they're like PIR sensors, essentially, and you've got 2 beams that it makes so that you can, so that your dog doesn't trip it, or, I want to say airplane for some reason. No, it will not be tripped by an airplane. Birds or anything else in your garden won't trip it off, but if someone hops into your garden, this thing can pick it up. And they work at 433 megahertz. So this is some of Skulk's code, which he was kind enough to share with me, where what he's doing is he's written his own implementation. Yes, it's still connected to his alarm, but now he can connect it to his Raspberry Pi and see when his garden services are there, if his kids are playing outside, and if certain hours where he's not expecting anyone else to be in his yard, it can let him know. And that's why he's got these tamper and check-in flags and everything else. And that's just how he runs it with RTL SDR. It's a really, really cool thing. Let's chat about antennas. So when you buy these dongles, you'll get one of these things, which is, of course, one of the simplest antenna types you can get, called a dipole. So you can make this yourself with a coat hanger if you like. This is just a piece of coax, and when you open that up, it's got shielding, a core, and I love saying dielectric insulator for some reason. It makes me sound very intelligent, but it's just plastic. And yes, I'm incorrectly labeling these ground in VCC because that makes more sense to me personally. But anyway, if you just attach 2 aluminum poles onto this, you have made a dipole. They're that easy to make. And you can tune them to different kinds of frequencies. So how does this work? Well, as electromagnetic waves pass by, they are inducing a current or potential voltage between these 2 different poles. And polarization is an important thing you'll hear about a lot when you mess around with this stuff. Who wants to guess? Yes, this is vertical or horizontal polarization. I beg your pardon, how did I mess that up? And vertical polarization. Point is basically, if you want to chat to someone, the polarizations need to match. But things get complicated with satellites with circular polarization, which we'll chat about in a second, because that gets a lot of fun. Anyway, so I can chat about antennas for a very long time. I just have one thing I want to get out of here. You all know about Yagi antennas? Please start calling them Yagi-Uda antennas, because it is Mr. Uda who had the greater contribution to the creation of this antenna than Yagi. That's the only thing I want to change about that. And if you want to make your own, how long should these things run, or how long should your dipole lengths be? That's always going to be proportional to your wavelength. So just how long that wave is over time. And your antenna needs to be half that. All right, so if you're making these yourself quickly, we'll talk about the half wavelength and the quarter wavelength, and for the sake of our antenna, we're going to talk about the total length and the element length of our dipole. And you're not going to sound smart at any conference unless you include some mathematics. So for the purposes of this talk, we are going to state the very well-known fact that wavelength equals the velocity of whichever medium through which something is traveling divided by its frequency, in which case this will be the speed of light, because it's radio waves, of course, which we can approximate to 3 times 10 to the power of 10 meters per second. So if we wanted to know what the length should be to pick up a signal at 100 megahertz, 100 megahertz is just 100 times 10 to the power of 6, so those 2 zeros can just fall in there, and notice that now I can cancel out 10 to the power of 8 divided by 10 to the power of 8, leaving with only 3 meters, and that's how easy it is to figure out how long your antenna dipole should be. Well, half that, remember. Yeah, anyway. Okay, so apparently I've got that wrong, and you need to come to me afterwards to show me how to fix that for my talk. I'm very welcome and open to feedback. Okay. Thanks. So for those of you at home, you can ignore the last 5 seconds of this, and we'll fix it in post. Okay. And I also approximated the speed of light, which might have upset some people. I'm sorry. Okay, let's talk about tracking ships. So this is what the ocean looks like, and it's always clear and it's always calm, and no, it's not. Sometimes it looks like this, and then it also gets dark. So it can be scary, and that's why on ships they have things like this, which help you track other why do I keep wanting to say airplanes? Other ships, you could track airplanes as well. You'd need some different equipment. We'll chat about that in a second. Anyway, they use a system called AIS, Automatic Identification System. And because I'm a software guy, I like to think of them as datagrams. Don't call them datagrams. I just like doing that. But yes, they'll come with something similar to, I don't know, what would this be, a packet error? Anyway, yes, you get this MMSI, Maritime Mobile Service Identity Number. You get a navigation status with cool words like at anchor and underway, a rate of turn, so which way the ship's pointed, I suppose, speed in knots, and then latitude and longitude. And it runs at 161.9. You don't care about the actual numbers. You can get those in post later. Anyway, if you want to make an antenna for this, you'll need to, well, it's probably wrong now, but anyway. I went and did this, and I made 44 centimeter dipoles. So I was down at, why do I keep wanting to say Camps Bay? This is down by the V&A waterfront. And if you look out there, there are ships out there. So we can figure out where they are, what they're doing. So this is SDR Sharp running in a virtual machine, and you'll already notice I lied to you. There are actually 2 types of AIS, AIS1 and AIS2, and they make these little chirps. Just go back and play this one again. They make these little chirps that you can pick up. And in Windows, there's something called Ship Plotter that you can use with a virtual audio cable through a virtual machine, which caused problems for me that you'll see a little bit later, but this is generally how you would do this on a Windows box. You can record these signals, and then you should be able to see all these ships, but this doesn't work so well on a Mac, and I was wondering what was the problem with this and all my virtual cables and virtual machines. So when I opened up Cubic SDR, and I could still see these coming through, and they were coming through even clearer, and I could record them as well. And by the way, yes, GQRX is a perfectly good alternative that works on Linux. I have nothing against GQRX, person who spoke to me about it at the last conference. Cool, so I could record these, which was fine, and then I could go back into Windows and take the WAV file from this using this thing called AISMon, which could at least tell me something about these files. And the interesting thing I had to do, I experimented a lot, but if you bring it down to 8-bit audio, so like telephone line quality, it seems to work. So, I mean, I've got a lot of errors over here, but there was definitely some data in here where it could find some stuff. So if I go then and take that same audio file and I put that into ShipPlotter, this is more the experience you'll use if you have a Windows machine, which is useless to this audience because I don't think anyone here has one, but anyway. Yes, that's what it looks like. And then you can see your ships. Pretty cool, huh? No internet, no hands. Yeah, and if you plot that on a nicer piece of software from the Mac App Store, generally this is what it looks like and how these things work. Let's talk about how you can build your own flight radar as well. Has anyone done this before? Okay, this is a lot of fun. This is a lot of fun. Who knows what type of plane this is? No guesses. It's a Boeing, yes. It's a Boeing 777. It's a Boeing 777. It's got 31 antennas on here, and we're going to go through every single one. I'm kidding, we'll just go through one. And that's for something called ADS-B. So that's your Automatic Dependent Surveillance Broadcast. Very similar to AIS, but designed for aircraft. So how this works, I just thought of some problems with this thing, but there's more coming up all the time. Anyway, aircraft generally know where they are, or should not generally, know exactly where they are thanks to technologies like GPS. And the idea of ADS-B is that you broadcast that to other aeroplanes and by the way, none of this stuff is illegal. It is a really good idea that everyone knows where aeroplanes are in the sky at all times. So yes, they broadcast that down to ground stations so that air traffic control can use this stuff, and of course to other aircraft in the sky as well through something called ADS-B in. And if you do find yourself in the cockpit of one of these planes, right next to the seat on this side is where you would put this in. I can't remember which YouTube video I stole this from, so I probably owe someone some credit. I've completely forgotten. I think it's Captain Joe or something like that. But anyway, what you've put in there is a squawk code. This will be issued to you by aircraft traffic control, and you'll pop it in before you get going. And then I can't recall which airport this is exactly. But yes, this is the view that aircraft traffic control normally have. That blue little part, there's the runway where everything's landing. And you can see here we've got squawk codes and flight numbers. There's some Dutch Airlines, KLM going. And this is normally and traditionally done through what they call primary and secondary surveillance radar, which are these dish things that are normally hidden in big domes at the airports that we normally visit. But in South Africa, our Civil Aviation Authority is very much pushing for the implementation of ADS-B to, as they say, replace legacy, less effective, and more expensive primary surveillance radar and monopole secondary surveillance radar. So these ADS-B datagrams, I'm a software guy, remember, I have that squawk code in there, the flight number, which in my experience is never populated for some reason. Your altitude, how high you are, your airspeed, longitude, and latitude. So of course, this broadcasts at 1090, and you need a much shorter antenna, only 7 centimeters. Am I wrong about that? You're nodding. Okay, cool, yeah, okay. And we use this piece of software called Dump 1090. Available in GitHub because I like open source things, and if you want to set this up in your Raspberry Pi like I do, same setup, except you hop on the command line. You guys know how to clone GitHub repositories, let's skip that one. But when you run this after you've made it, you need to add on this interactive mode, otherwise it just starts streaming stuff into the console, and that -- net will be important. So I did this at the airport in the slow lounge. My wife was not amused at all with what I was doing. And you can see here, we've got an SAA flight, we've got an SFR or SFR flight over there, a big question mark flight, they don't know where they're going. Interesting part about this is a lot of them have no speed and no longitude and no latitude, and I imagine this is because a lot of planes are parked, but they leave the ADS-B transponders on, so they keep transmitting, but they don't have a location, or I've got excellent range and they're all parked at Point Nemo. So that's generally what this looks like. And if you want to, that -- net allows you to add on, if you just, well, I use localhost in this instance, but anyway, you can just go plot this using Google Maps. You do need to go register to get your own Google Maps API key and then fix it in the JavaScript code to get this working. But yes, here I've got 3 different planes, and you'll recognize there is ORT in Johannesburg. So lots of fun. Who does the who uses Flight Radar 24? At all. So there's this whole community thing, yeah, lots of planes being tracked by these guys, and you can contribute data yourself. So if you live in a remote area or somewhere interesting, they've got a whole guide where you can use a Raspberry Pi in one of these dongles and contribute data by just running this as sudo, just grabbing commands that start with sudo off the internet and putting them into your Raspberry Pi. Yeah, I'm sure it's safe. But anyway, yeah, this goes and pulls down an installer and sets the whole thing up. So this presents new and interesting opportunities for us to go to jail. None of what I've spoken about is authenticated or encrypted at all. And who remembers much earlier this year, Gatwick Airport was shut down for more than a day, I think. Millions of flights were redirected. And I've got a friend who owns a company that does, like, if you want to charter a plane from one country to another or do private flights and medical flights and stuff like that. So he's not in aircraft traffic control. His company does all the ground handling, and I had some very interesting discussions with him about how you could cause more interesting problems with this. And I asked him what would happen if on, let's say, April 1st, for whatever reason, goodness, I'm so nervous with you in the room about this. I'm so going to end up on a do not fly list. I'm a Dutch citizen as well, so we can't work together at all. But anyway, yes, if on April 1st you had to put in, so here's the thing about score codes. Any score code that starts with 7 is a major emergency, okay? I think 7,000 means that plane is definitely hijacked. 7,600 probably means that you're disagreeing? You're trying to remember, anything with 7 is bad. The best one that starts with 7, I don't know which one this is, but it says that all your radio communications are out. So I'm landing, aircraft traffic control, please get everyone out the way. So I asked him what would happen if I had to create a 7,000 score code, and then in the same way that I can create any transmitter using a Raspberry Pi, I could just attach it I haven't thought this through very well, but anyway. Let's attach it to a battery bank, go to the airport close to where they're picking up these ADS-B signals, leave it in the trash, run away. Oh, I'm so worried about this suddenly. But anyway, yes, if this thing were, it would then broadcast a fake, like a ghost airplane. And you could fly this plane all over the place, or straight through the aircraft traffic control tower. And I said, what would happen? And they said, well, they would bail and run. So I haven't helped him get a day off work yet, because he doesn't actually work in the tower. But I mean, like, I don't think these folks are thinking about the types of problems that you guys are thinking about in the software security space. So I was thinking, well, could you do an ADS-B DDoS attack? So who recognizes this airport? Sorry? Cape Town? No, it's not Cape Town. It's way too big. This is Dubai International Airport. It's quite sandy here. And the reason I've chosen this one is because it's one of the biggest connecting, where like connecting flights come through. And this causes massive, massive problems with diversions and everything else. If one of these airports had to go down, they will redirect any and all flights coming in to anywhere else, all right? So you don't need to hit a large amount of airports. You just need to hit a couple of, like, you know, JFK, Heathrow, Schiphol. And you can cause absolute chaos with this sort of thing. Because if you're in aircraft traffic control and you're just seeing a couple of planes, what's your day going to be like when this happens, right? And the problem here really is that you know, your normal radar, the whole reason why these airports can even operate the way they do is because they're using ADS-B. They're not using radar anymore because it doesn't give them the resolution. They can't see height or anything else. So they're becoming very dependent on this kind of thing, and there's no security around this stuff. But yes, like I said, I am not the first one to chat about this at all for I think it's more than 5 years. We've been complaining about security problems in this. So if you play in this field, yeah, please let us know. So, of course, you guys actually came here to talk about satellites, so let's get into that. This is NOAA, the US's National Oceanic and Atmospheric Administration, long blah, blah, blah. These guys exist because of the Titanic. This is not only my theory, but they started tracking icebergs. So they're quite an old institution, and they've got some nice weather satellites like this one. I don't know which exactly this one is. There's a couple of NOAA satellites. 3 of them are in orbit at the moment. And they're in these they go like, think of them as fax machines. They just go over the Earth from pole to pole all the time. They're in polar orbit, and they've got different names. So the US uses NORAD IDs to identify everything because you're interested in knowing what is a potential nuclear missile and what is not, and you can probably tell us more about that, while the rest of us use these international codes which tell us what date it was launched and some more information. And these things are quite heavy. It's like heavier than my car. And they travel 28,000 kilometers per hour, which is quite impressive. And they circumnavigate the world every 102 minutes. And the view you're going to get from any cameras on these things is from 850 kilometers above. So you're not going to get Google Earth kind of stuff here, just warning you in advance. So the NOAA satellites operate at 2 primary frequencies. They do a lot more than just this. But at 137.1 megahertz, they use something called automatic picture transmission. And then there's a higher resolution version of that, which I don't use because I'm not steady enough to hold the antenna and track the satellite as it comes over. So funny story about NOAA 19, it fell over. This must have been such a bad day at work for these guys, right? $137 million because the bolts weren't properly attached. I don't think anyone got fired. I don't know the whole story. But when I do this myself, I get the best signal from this one. So they probably fixed some stuff. I don't know. What did they call it? Percussive maintenance? Yeah? Okay. It's a funny story about NOAA 16. It used to have only 1 NORAD ID, and now it has over 200 because it blew up. And no one knows exactly why. Listen, I'm so impressed with these things. I'm really not trying to make fun of them. I mean, to get this stuff to work in this environment is amazing. You know, imagine if your laptop battery blew up and there were 200 pieces of laptop everywhere. And those are only the pieces, oh wait, have we gone down again? No. Those are only the parts big enough for them to see. You know, they're much smaller little paint flecks and things. So this is half a rant about space garbage. We'll see some of that in a moment. Anyway, how do we find satellites? There's tons of software to do this. Orbitron is something you'll see recommended quite often, but it's got quite a crap and confusing UI. Probably perfect for when it was written, which feels like the 90s. So I'm going to skip over this one. So let's not worry about that. This is a much nicer version called gpredict. So there's NOAA 19 over there, and I can select that one and get some more information around when it's going to be coming over. So it tells you the date and the time around when you can expect that satellite to come around again. The one I like is N2YO. So this is the website, and you can use that. Oh, 10 minutes already. Anyway, we'll try to go through this a little bit faster, but this is how you can find when a satellite's going to come over. So put in your coordinates of where you are. It picks it up from your IP address, so it's quite easy, and it'll tell you when that satellite's going to come around. So it'll be in the sky for about 10 minutes as it comes over. No, you can't see it. A guy called Charles recommended a very cool alternative to this called Celestrak. So speaking about space junk, check this out. There's a lot of stuff up there. And anyway, there's a search function down at the bottom that you can't use that you can use to find some of these things. And if you're a developer, there's something called ORE-Kit. If you're a Java programmer, you can automate a couple of stuff. There's also a command line version of gpredict that I wouldn't recommend too much. But anyway, we have to make some antenna modifications to get this going. So to deal with circular polarization, we'll go for 120-degree change over there. 437 megahertz, we need to do 54 centimeter long element lengths, and you point that thing north-south. So literally, this is what I had. That's my balcony up where I live in Pretoria. And it was pretty much something like this, just a little bit longer. And you sit out there at 4:30 in the morning waiting for satellites to come over. And you'll see in this waterfall, this is cubic SDR again, there's something happening over here as this thing comes over. And a little bit later, you can see signals improving. And I hope this doesn't hurt anyone's ears because there is an audio section a little bit later. But notice how this ATP signal is coming in. And notice how it's just bent a little bit. Who wants to guess why that is? It's the Doppler effect, absolutely. So this thing is moving so quickly that the frequency shifts ever so slightly because of the speed at which it's moving, which is really interesting. Do you want to hear what this sounds like? This might be super loud. I'm sorry if it is. Wait. It's maybe better that you don't hear it. They probably turned it off. But anyway, how do you decode this? Well, like I told you, this thing's like a fax machine. So these were the old Nimbus satellites, some of the first weather satellites you had out there. So you use something called automatic picture transmission, and everyone will tell you to use WX to image, which I used in a virtual machine but could not install, and it didn't work out really well for me. So I switched to an open source version. You'll see this thing break, but I'm a little bit worried about time, so we'll go forward on that. What I recommend is NOAA ATP. A very nice website that shows you how all the decoding of these signals can be done and how you find the different wedges for all that. But in any case, it's just a project you can run. So I did this on an old Kali Linux box of mine, so probably appropriate for this audience, I guess. But it comes with a little GUI, and you can go for start and go grab. So I did this for DevConf initially. So that's some signal from NOAA 19. Choose an output file. I'm just going to call that devconf1. I'm typing my thumb. Is no one impressed? Oh, that joke's gotten old quickly. All right, sorry. And you start, and this is in real time. I didn't speed this up. There we go. Filter this out. Well, Kali Linux, everything is root. You just root in what, Tor or TWR. That's, yeah, I only did this one time. I've actually put something else on that machine because I know what you're all thinking now. Who wants to see the results? Yeah, of course you do. That's why you came. Awesome. So this was one of the first ones I got. Okay, so it's bad, right? But think about it. I've got a signal from space with a 300 Rand dongle and the equivalent of a coat hanger. I was very impressed with myself. And further passes got much better results. So here you can see definitely there's some clouds, there's some weather, there's something. So what was the problem? First was location. I just relied on N2YO using my IP, but you need to be quite specific about your location so that you can track the timing exactly of when that satellite is going to rise and set, if you like. Line of sight is also very important. These signals do not travel very well through buildings or trees or anything else like that at all. And your antenna needs to be much better. So there's this website called Giga Technology, which I'll recommend. They've got a very cool cross dipole. There is a whole plethora of designs for these types of antennas out there, so this is by no means the only one, but less hacky than the thing I was using. And you can filter out some stuff, which I'm going to skip over, and then the results start looking much better. Much better. Who can tell me what's wrong with this image? Yes, because we're running out of time. It's upside down because these things are moving, north to south and south to north, and you never know which way it's really moving. So, and what you're looking at over there is some thermal infrared and some near visible, but it's all black and white, of course. Shall we play with some Russian satellites? Have we got time for that? Cool. So they've got something called Meteor M2 satellites. It's actually version 2, 1, and 2. The first one, I think, didn't properly separate from its booster, so it sort of tumbles, and then they turn it off, and then it turns itself on again and starts broadcasting. There's a whole thing about, if you go to RTL SDR, I'll recommend this. There's like 30 different dead satellites that they put in these graveyard orbits, and then they just turn on again. But yeah, no, this is an actual functioning one. Same deal, twice as heavy, same idea, a little bit closer, same-ish frequency. And this is what it looks like. It's a digital signal this time. And I had a lot of trouble with this. You've got to demodulate this. They use something called LRPT, or low rate picture transmission. It's digital, it's slow, but that's what we'd expect. And it requires lock for the Doppler effect. So if you're doing this, there's a whole long tutorial about how to do this, but I like the open source stuff and thought this is way too much work to use all those Windows programs. So I use something called Meteor Demod. And when you're running that, and you've recorded this WAV file using SDR Sharp, which you need a plugin for, by the way, to maintain that, to compensate for the Doppler effect and the movement of this satellite. There you've got lock. It's busy getting some data. And then you've got to decode it, which didn't work this time. So I struggled with that, and I couldn't figure out why, which is a long story I won't get into. But other people have had very good results. So someone posted this on Twitter. I forgot to credit them. But there's Cape Town down on that side, and you can see this is a digital signal on that side. So really, really nice stuff from the Russians there. If you want to use, International Space Station is another fun thing that I've been trying to mess around with. Won't get into too many of the details of that, but of course, find out when it's going to come close to you. And I did this using a Raspberry Pi, actually, just using RTL SDR software FM. So it's just a command line. You can record it. It creates a WAV file or an IQ file for you. So put in the frequency, give it a nice name, let it run, and you just set this up while the International Space Station is coming over. And they use this whenever they're doing any amateur radio talks or anything else, and I had these expectations about them maybe complaining about the food or each other, or maybe picking up something scandalous they can say on the radio because they're over Africa and not in the Northern Hemisphere. Nothing like that happened at all as they flew over. This is not a video they sent me. I don't even know where this is. But it's the view of where it comes from. Control-C to exit to pick up that file, and yeah. That's all I heard. Sorry about that. So what you need to do is go to the amateur radio on the International Space Station website and find out when they're going to be talking. Okay. So sometimes they speak to schools or community events and stuff like that, and you'll only hear one side of the conversation because you're not going to hear the people speaking up to it. You won't get that. You'll only hear that one half of the conversation at least. But yes, and they also do these weird kind of, I almost think of them as memorial plaques, but they send down slow scan television images, which look like this in SDR Sharp. Yeah, a little bit grainy, but quite fun to do. So other fun things to try. In conclusion, who has been to one of those terrible restaurants we have in South Africa where they tie like this thing to the waiter and the waitron, I have to say, and and then you can call them with a button on the table. Who's been to those? Am I the only one who has those? That uses the same technology that pages use, and you can really mess around with that stuff. So that's a fun thing I might want to try. You can spoof something called RDS TMC, which is a fun way. So this is the inside of my car. It uses TMC Pro to be able to tell where there's traffic. So I know this is encrypted in Europe. I don't know if it's encrypted in South Africa. But it might be a fun way to say that every road you're driving on is busy and everyone should get out of the way. That might be a fun thing to do. You can create your own cellular networks with something called OpenBTS. The Sammy Kamkar has this cool talk called Drive It Like You Stole It, where he talks about how you can basically defeat French encoding and all that with some cool jamming techniques. You can build your own space telescope and yeah, like literally listen to pulsars, which is really cool. You can spoof RFID tags, and I don't know about this one, but it might be fun. They'll explain ETOLs later. And this is the coolest thing I found. It's something called SMB radio. So remember how my Raspberry Pi has a little bit of EMF leakage? So all computers have a little bit of EMF leakage. And there's it's actually, one of the demos is in JavaScript. I don't actually have an old-timey radio that can go down to, I think it's only 5 kilohertz is the frequency at which it can broadcast, but it literally uses the EMF leakage from your system bus to play Mary Had a Little Lamb. It is incredibly cool. So who knows who this is? Very close. I won't keep you into this. It's Heinrich Hertz. And the last message I just want to leave you guys with is, they were chatting to him many, many years ago, not on an iPhone. And when he's the guy who discovered radio waves. That's why we talk about Hertz as the only SI unit with a S in it, because it's someone's name. And well, when they asked him what the point of this was, he said, well, there's nothing whatsoever. He was very impressed that he'd found a way to prove Maxwell's equations of electromagnetic induction. And they asked him about any applications, and he said, nothing, I guess. And if you think about the applications of radio and Wi-Fi and everything else that we use today, that's maybe a point to make. So if we think today about what we do with the cloud, we've basically taken computer infrastructure, defined it via software, and called it the cloud, so you can hop on to GCP or anything and make your own VM. What could you do with software-defined radio? And it's interesting, AWS is doing this cool ground station network. So you can imagine creating your own points around where, am I totally out of time? 2 minutes. Okay, we'll just close this up. You can imagine as your satellite is maybe moving across the planet, as it moves close to that AWS ground station with that data center, you can spin up an instance of a server that could download that information, process it, pass it along, and you don't need your own ground stations for anything at all. So I'm completely out of fuel. I've got some credits for some of the guys who've worked with me on this, the OXCon guys who gave me some advice on this stuff. Thank you for Nedbank for doing my flights and stuff. I'm speaking at your conference on the 31st, probably. I don't know. Next year at DevConf, and that is me. You guys can follow me on Twitter. Thank you very much. That's me. Okay, they have allowed me 2 questions. So not all of you at once, please. Only, okay. Gentleman in the back with the incredible beard. You should have seen me at Movember, hey? Okay, first of all, okay, the question is, when am I getting my ham license and when am I playing with QSO 100? So I'm thinking maybe next year when the exams are in April next year, I think, will probably be the next opportunity. Okay, so that's what I'm going for. I'm slowly gearing up on We Prepare. What did you say? What's QN? What 100? What is that? Oh yes. Oh. So I've got the content for my next talk here. I'm sorry we probably don't have the audio from all of that, but that sounds incredible. Okay. And someone might, okay, awesome. One more question. Right, so the question is, what are the plans around encrypting air traffic data? I have no idea. Okay, I did have this idea that, you know, let's put blockchain on it, and of course, no. But, you know, it could be, I don't know. You know, I think that, I don't know. I don't know. I should know, but I don't. That's terribly embarrassing. Thank you. All right, no, that's all from me, guys. Thank you very much. Cheers.